This is part two of a series of videos on revision on the chemical world topic, looking at atoms, elements, and the periodic table. So the previous video, I talked about atoms, their parts of an atom, the periodic table, how elements are expressed, and how you can determine things like number of electrons, protons, and neutrons. Let me now get into ions. So ions, an ion, is another word for charged atom. So I mentioned before, in the previous video, that the atoms that we encounter every day typically are neutral. So an atom typically looks like this, a seesaw. It's got a balance of plus and minus charges. Balance of plus and minus gives you a neutral atom, okay? Hopefully the table that you touch, the pen that you use, the paper that you touch is neutral, okay? If not, you'll feel a zap. So atoms are typically neutral. Now, to make an atom charged, let's take the case of helium. Helium looks like this. Oh, actually not helium, let's do lithium. 3 protons, 4 neutrons, 3 electrons. Let's take lithium. Lithium is a metal, commonly found in rechargeable batteries. If I take 1 electron away from the lithium atom, it'll look like this now. Okay, so the nucleus doesn't change, it stays as it is. So remember, chemical properties, chemical behavior is to do with electrons, not the nucleus. That's nuclear science, something else. I'm now left with 2 electrons. Okay, I've taken 1 electron away, 3 minus 1, that's 2. There's now an imbalance of positive and negative charges. There's 3 protons plus 3, right? 2 electrons minus 2. So the net charge, the overall charge, 3 minus 2, gives you plus 1, right? There's 3 protons, 2 electrons. The net charge of the overall charge is plus 1. Okay, there's 3 protons minus 2 electrons is 1. This is a lithium ion. Now you know where the word lithium ion battery comes from. Lithium ion, so the way we write ions is, so we write the chemical symbol, which is for lithium, which is Li. So literally the periodic table, that's all you have to use here. Plus 1. Now typically it's written as plus on its own. I like to write plus 1. Okay, particularly when I'm teaching students, easier for them to see what's happening. Plus 1. Now the plus 1 means, reading it from right to left, loses 1 electron to become positive overall. Reading it from right to left. So it loses 1 electron to become positive. Metals want to lose electrons. They prefer to lose electrons. It's more favorable for them, okay, in terms of energy. Because if you look here now, at lithium now, it's got a full outer shell. It's got 2 electrons, okay? Rather than gaining 7 electrons in the second shell, it's better off giving away 1 electron, okay? Makes it easier. They lose electrons and they become what are known as cations. A cation is a positively charged ion. It's just a name. Think of cool, calm, and collected. When you're cool, calm, and collected, you're happy, you're positive. Okay, just think of cation as that. C for cool, calm, and collected. Metals want to lose electrons to become positive ions. Okay, you need to know this. Non-metals, on the other hand, non-metals want to gain electrons. It's more favorable for them to gain. And they become anions or anions, negative ions. Okay, metals, positive ions, non-metals, negative ions. Let's do an example of a non-metal. Let's do chlorine. Chlorine has 17, so I'm just going to write Cl for the nucleus. I'm not going to draw 17 protons. Atomic number of 17, so 17 protons. Let's draw the 17 electrons. There's 2 in the first shell. That's the rule. And then 8 in the second. 2, 4, 6, 8. And then 7 in the third. 2, 4, 6, 7. Now in the third shell, maximum number of 8. Chlorine is missing 1. It's favorable for chlorine to gain an electron. Now it's got a full outer shell. So we write chlorine as Cl minus 1. From right to left, it gains 1 electron to become negative. Okay, before it was neutral, the chlorine. If you give it more electrons, it's now negative overall. Just the trick with the periodic table, you need to know this for the exam. Group 1. Okay, so from left to right of the periodic table, there's groups, there's columns. Okay, I'll write equals column. Group 1, that's the alkali earth metals, okay? This is lithium all the way down to francium. You can check this on your periodic table. In fact, I encourage you to get out your periodic table now if you can. Alkali metals. Alkali metals. Lithium all the way to francium. Group 1, and you can work this out, but the trick with this is just to memorize. Group 1 has a valency of +1. Valency means it's combining power. So all of these elements in group 1, they want to lose 1 electron to become positive. Right, that's group 1. Group 2, these are the alkaline earth metals. These are beryllium all the way through to radium, Ra. +2. They want to give away 2 electrons to have a charge of plus. Right? Groups 3 to 12, these are called the transition metals. Transition metals. Most of the periodic table is metals. Okay, I'm going to put in here depends. The valency depends. They'll tell you in the exam. They'll give you Roman numerals like 1, 2, 3, 4. They'll sometimes write something like copper. So copper is a transition metal. They'll write maybe copper 2 in brackets. So in brackets after the copper, they'll put 2. This means copper has a valency Cu, symbol copper, +2, because it's a metal, right? So transition metals, and then you got group 13. Running out of room. That's all right. Group 13 has a charge of +3. Okay, this includes elements from boron all the way down to thulium, if I can pronounce it. So +3. They want to lose 3 electrons to become positive. Then you have group 14. Just squeeze it in here. Group 14, from carbon all the way through to lead, Pb. It's either -4 valency or +4. It really depends on the question they give you. Minus or +4. Let's do an example. For example, carbon. Okay, if they give you, let's say, I don't know, carbon and chlorine stuck together. I'll talk about this in another video, looking at writing chemical formulae. If you separate these two out, so chlorine, valency of -1. The carbon has to have a valency of +4 in this case. Why is it plus? Because plus and minus cancel. Compounds are made of plus and minuses, plus and minus ions. You can't have a minus and minus. They repel. Plus and minus attract. Okay, opposites attract. That's group 14. Group 15. I put for short G. Group 15, running out of room. Group 15 is nitrogen all the way through to bismuth, Bi. Valency of -3. These are non-metals. They want to gain 3 electrons to become negative. Group 16 has a valency, so from oxygen all the way through to polonium, Po, a valency of -2. They want to gain 2 electrons to become negative. Group 17, valency of -1. Okay, elements of fluorine all the way through to astatine. And group 18, the very last group on the right, has a valency of 0. This is the noble gases. These are inert. Inert means they're unreactive. Okay, this is elements of helium all the way through to radon, Rn. So it's worthwhile memorizing all these valencies from +1, +2, depends in the middle, then +3, plus or -4, -3, -2, -1, 0. So that's valency in ions. In the next video, I'll talk about how to write chemical formulae, so how to combine different elements to write compounds.